Alright, so in today's lesson we're going to be looking at how to match graphs to linear equations. So for example, if you're given a graph like this and linear equations like these, how can we figure out which one matches it? Well, in today's lesson that's what we're going to figure out. Alright, so now that we've learned how to draw graphs of linear equations in slope-intercept form and standard form, so slope-intercept form is y equals mx plus b, and standard form is ax plus by equals c. What we want to know is how can we match a graph that we're given to a linear equation. So, how do we match a graph to a list of linear equations? So if we have multiple linear equations, how can we match it? So here's one method to do this. So in this method, step 1, what you're going to do is select 2 points on the graph to make your calculations easier. So you want to try to make your points nice points. So what we want to do is select hopefully the x-intercept, so we're going to call it point A0, and our y-intercept point 0b, and you want to have these points have integer values for both a and b, because when we get decimals it makes it a little bit trickier, but it's not impossible, but we're going to start with some nice numbers. Alright, step 2. What you're going to do is then plug these points into your linear equation, or equations, depending if you have more than one, and you're going to see if the left side equals the right side. Then you're going to do this, and you're going to keep doing this until it works for both points. So once it works for both points, then you know you have the correct equation. Alright, so now that we know this method, let's try it with an example. So which of the equations matches the graph? Okay, so we're given a nice little graph, and we're given the equations. So our first equation is y equals negative 2x plus 4. Our second equation is y equals 4x plus 4. And our third equation is y equals 2x plus 4. So like before, in our steps, step 1, find 2 nice points. So we're going to use our x-intercept and y-intercept. So we know our y-intercept occurs at 0 and 4, and our x-intercept occurs at negative 2 and 0. So we're going to take these 2 known points and we're going to plug them back into our equations and see if the left side equals the right side. So let's start with our first equation. So we're going to use our y-intercept first, and we're going to plug it into our equation y equals negative 2x plus 4. And we want to see if the left side equals the right side. So wherever you see an x, you're going to plug in a 0, and wherever you see a y, you're going to plug in a 4. Okay, so rewrite your equation. Now plug in your x and y values. So we now have 4 equals negative 2 times 0 plus 4. And what's nice about using zeros, whenever we multiply by 0, everything goes away. So we're left with 4 equals 4. So we know our y-intercept works for this equation. But now we need to see if it works for our x-intercept, which is negative 2 and 0. So when we plug this in, we get 0 equals negative 2 times negative 2 plus 4. So now let's simplify this. So 0 equals 4 plus 4. So 0 equals 8. Now 0 does not equal 8. So this point does not work. So we know that our first equation does not satisfy both points. So it does not work for this, and is not the corresponding graph. Alright, let's look at our next equation. So our next equation is y equals 4x plus 4. So if we plug in the points for our y-intercept, 0, 4, we get 4 equals 4 times 0 plus 4. So when we simplify this, 4 times 0 goes away, so we're left with 4 equals 4. So that works out. So we know that it does work for our y-intercept. But now we need to see if it works for our x-intercept, which is negative 2 and 0. So when we plug these back in, we get 0 equals 4 times negative 2 plus 4. which simplifies to 0 equals negative 8 plus 4, and finally gives us 0 equals negative 4. Now, these two are not equal, so this equation does not work. Now, we're hoping that our third and final equation is the right one, but we won't know until we actually plug in our values and see if it does work. So if we plug in our y-intercept first into our equation y equals 2x plus 4, we get 4 equals 2 times 0 plus 4. So the 2 times 0 goes away. So we're left with 4 equals 4. So y-intercept does work. Now, does it work for our x-intercept, negative 2 and 0? So when we plug it back in, we get 0 equals 2 times negative 2 plus 4. And this simplifies to 0 equals negative 4 plus 4. So negative 4 plus 4, they are opposites and cancel each other out. So 0 equals 0. So this does satisfy both points. So our equation for this graph, linear graph, is y equals 2x plus 4. Alright, now let's look at another method for doing this. But we're going to use the same graph from the last example. So step 1, what you're going to do is you're going to write out the general equation of the line in slope-intercept form. So you want to make it so it's y equals mx plus b. Step 2, what you're going to do is find 2 points with nice integer values for x and y. So we already found those in this last example. And this is going to help us find our slope. So remember, your slope is the rise over the run, or for if you're given 2 points, the rise is, so the change in the rise is y2 minus y1 all over x2 minus x1. So if we label those, that's how they would match up with our corresponding x-intercepts and y-intercepts. Now, you can interchange these and you'll still get the same answer, but you need to be consistent. So for our slope, our rise is going to be 4 minus 0 over 0 minus negative 2. So our slope is 4 over 2, or just 2. So we know our slope is 2. Now, in step 3, what you want to do is once you have this figured out, you're going to pick one of your known points, so x, y, and you're going to plug it into your equation along with your slope m, and then you're going to solve for your y-intercept, which is the b value in your general equation. So we're going to pick the point 0, 4, which is our y-intercept, and we know m equals 2, which is our slope. So given our general equation in slope-intercept form, y equals mx plus b, we're going to plug in all of these values. So wherever you see an x, you're going to plug a 0. Wherever you see a y, you're going to plug in a 4. And m is 2. We're going to solve for b. So we get 4 equals 2 times 0 plus b. Now 2 times 0 goes away. So all we're left with is b equals 4. So that tells us where it crosses our y-intercept. So when we plug this back in with all of our values, we know our slope, which is m, and m equals 2, and we know our y-intercept, b, equals 4. We now have our linear equation, which equals y equals 2x plus 4. So this is another way you can do it, but it just depends on what your preference is or what the question is specifically asking you. Alright, so let's look at another example. So which graph matches the equation y equals negative 3/4 times x plus 2? So I have 3 different graphs here, and I want to match it to this linear equation. Now, since I have a linear equation in slope-intercept form, it's a little bit nicer because I can figure out where my y-intercept is. So b equals 2, so that's where it crosses the y-axis. So I want to see which graphs cross at positive 2. So all of them do, so that doesn't help us too much. But if it does for some and not others, then you know you can cross them out. After this, what we want to do is look at our slope. So our slope m, our rise over run, is negative 3 over 4. Now, since our slope is negative, it is going to be going down from left to right. So we know our first graph on the left does not work because it's going up, so it has a positive slope. So it has to be our middle or our right graph. So now we want to use our y-intercept and find the next point on our graph and see what the slope is. So our middle graph goes down 3 and right 4 to our next point on our line. So we know that one works. So let's check our third graph. So it goes down 4 and to the right 3. So this one does not work because our slope is negative 3 over 4 and not negative 4 over 3. So we know it has to be our middle graph. So that's why I like using slope-intercept form, because it gives you a lot of the information you need to find your graph. Alright, so let's look at one more example. So which graph matches the following equation? Okay, so now things are a little bit different. Now instead of giving an equation in slope-intercept form, I've now given you an equation in standard form. So it's a little bit trickier. I can't just find the y-intercept and the slope. So I'm going to use one of our other methods to figure this out. So we need to first find our y-intercept. So let's just look at our graph. So to find our y-intercept, we know that for this to happen, x has to equal 0. So at the point 0y. So if we plug this in, we get 0 plus 2y equals 4. So we know 2y equals 4, and we're going to solve for y. So divide both sides by 2. So the 2's on the left side divide each other out. And then we're left with y equals 4 over 2, or y equals 2. So we know that our y-intercept occurs at 0, 2. Now what we need to do is find the x-intercept. And this occurs at y equals 0, or when we don't know the value for x, but y is 0. So when we plug these in, we get x plus 2 times 0 equals 4. And remember how I said before, what's nice about using x and y-intercepts, whenever you plug those values in, things just disappear. So 2 times 0 goes away, so we're left with x equals 4. So we know our x-intercept occurs at 4 and 0. So now what we got to do is match these points up and plot them and see which line they fall on, and that'll show us which linear graph matches this equation. So in our first graph, we get a y-intercept of 0 and 4 and an x-intercept of 2 and 0. In our second graph, we get a y-intercept of 2 and 0 and an x-intercept of 4 and 0. So from what we've just found out, we know this matches our second graph. So just through this process of finding our x-intercepts and y-intercepts, we can easily find which graph matches our equation in standard form. Now we're given nice integer values, which makes this very nice, but if you were given equations with fractions or decimals, that might be a little bit more tricky. But this, as long as you follow these methods, you can match any linear equation to your graph or vice versa. So hopefully this helps, and until next time.